We are gonna solve problem 12 of AIME I 2020. We'll work on 6 ideas and I leave 2 homeworks. And as I said before, there are around 40-50 important ideas in each topic: combinatorics, algebra, number theory, and geometry. If you want to learn them, feel free to send message to my WhatsApp number in the description. Now, first I want to show you 6 ideas if you want to try this problem 12 before watching the rest of the video. Pause the video and try this problem first on your own. Now in next step, I want to show you 6 ideas. After that, we will solve the problem. Okay, because maybe you cannot solve this one. It's better to see all ideas before solving that if you couldn't. So 6 ideas are what: LTE, if P is an odd prime, P doesn't divide X, doesn't divide Y, P divides X minus Y, VP of Xn minus Yn is VP of X minus Y plus VP of N. VP is what? Power of P in that number. For example, V3 of 24 is what? We call it lifting the exponent, this theorem. V3 of 24 is power of 3 in 24, 1. V3 of 18, for example, is what? Is 2. Idea 2 is this one. I will explain in the rest of the video all parts completely. Idea 3 related to order in number theory. It's important you learn. Idea 4 is that when a to the k is 1, order divides that. And idea 5 is this identity. Idea 6 is this formula, number of positive divisors. Okay, I will explain all of these 6 ideas completely during solution. Okay, so let's try the problem. AIME I 2020 problem 12. Let n be the least positive integer for which 149 to the n minus 2 to the n is divisible by 3 to the 3 times 5 to the 5 times 7 to the 7. Find the number of positive integer divisors of n. Try this one first on your own. Okay, idea 1 that we should use for solving this problem is LTE. Okay, lifting the exponent. It is what? LTE has around 4 types. One type here useful. If P is odd and P is prime, okay, or let's say P is an odd prime number, then we can say what? If P doesn't divide X, P doesn't divide Y, but P divides X minus Y, then we can say VP is the maximum power of P, or power of P when you prime factorize. In Xn minus Yn, for example, V3 of 24 is what? Because 24, the power of 3 is what? 3 to the 1 is 1. V3 of 18 is what? 3 squared times 2 is 2, okay? Vp of x minus 1 equals Vp of x minus y plus Vp of n, okay? Now use LT and solve this problem. So pause the video and try first on your own. Here let's consider P3. P3 first here. Let's see, does it satisfy the conditions of LTE? 3 is an odd prime. 3 we want to apply for this. 3 doesn't divide 149, it's good. 3 doesn't divide 2, good. 3 divides 149 minus 2. 149 minus 2 is 147. Sum of the digits equal to 12. So this condition is satisfied. Now with 3. With 3 of 149 to the n minus 2 to the n equals V3 of 149 minus 2, if we use this formula, plus V3 of n. It will be V3 of 147 plus V3 of n. Sum of the digits of 147 is 12, so it is only multiple of 3, not multiple of 9. So V3 of this is 1. 1 plus V3 of n. Now, from assumption of the problem, we know that this number should be multiple of 3 cubed. So power of 3 should be at least what? Power of 3 of this number. It is multiple of 3 cubed. So power of 3 in this number should be at least 3. So if we pay attention to this inequality, if we subtract 1 from both sides, V3 of n is at least 2. So when V3 of n is at least 2 means that power of 3 in n is at least 2. So n should be multiple of what? 9, okay? When power of 3 in n is at least 2, so n is multiple of 9. It's the first condition that we proved. Okay, so let me copy the problem and or let's okay. I think if we okay. Now you can see what we did here. After P3, try to work on, so we've applied 3. 7 is easier, 5 a bit harder. So try to work on 7 first on your own. Okay, let's apply 7. Now, if you consider P7, 7 doesn't divide 149. Let's see. Wow, 7 divides, let's check. Doesn't divide, yes. 7 divides 147. 7 doesn't divide 2. 7 divides 149 minus 2. 147. 147 is 7 times, it's 49 times 3. Or 7 times 21. So V7 of 149 to the n minus 2 to the n equals V7 of 149 minus 2 plus V7 of n. It will be V7 of 147 plus V7 of n. 147, as I said, is 49 times 2, so power of 7 is 2 plus V7 of n. Now we know, because from in the assumption of the problem, it says this number should be multiple of 7 to the 7. Here. This number should be multiple of 7 to the 7. So we can say the power of 7 in this number is at least what? Is at least 7. Now, if we subtract 2 from both sides, V7 of n is at least what? At least 5. So we can say what divides n? 7 to the 5 divides n. This sign is the divisibility sign. If you want to know the properties of that, feel free to send message. My WhatsApp number in the description. Okay, now we've considered this. Next one so we've applied these two things. Next one, this one is a bit harder. 5 to the 5, because 5 doesn't divide 149 minus 2. But we can do something to be able to apply LTE. So try this one first on your own for 5. Pause the video and try. Now let's apply 5 to the 5. We know 5 to the 5 is a factor of this number, 149 to the n minus 2 to the n. So let's write it here. 5 to the 5 divides 149 to the n minus 2 to the n. If you want to apply LTE, 5 doesn't divide 149. 5 doesn't divide 2, that's okay. And 5 should divide 149 minus 2, which is 147. This part is wrong, so we cannot apply LTE in the first step. So what should we do here to get rid of this problem? First, let's consider that 5 should be also a factor of 149 to the n minus 2 to the n. And here we can use what? We can use modulo. Means what? 149 to the n is congruent to what mod what? Is congruent to 2 to the n mod 5. And 149 mod 5 is negative 1 or 4. 4 is better here, I will tell you why. 4 to the n is congruent to 2 to the n mod 5. Now idea 2, we have a rule in geometry. That is what? Idea 2. If AB is congruent to AC mod M, and if we want to divide both sides by A, B is congruent to C, but instead of M, we should write M over GCD of M and A. Okay, as homework 1, try to prove this. And if you had question about this or want to learn more ideas, feel free to send message my WhatsApp number in the description. Okay, now let's divide both sides here by what? Divide both sides by 2 to the n and use this idea. So if you divide both sides by 2 to the n, then we can say 2 to the n is congruent to 1 mod 5 over GCD of 5 and 2 to the n. Because 5 is an odd number, GCD of 5 and 2 to the n is 1. So it will be mod 5. Now I want to see for which n we have this. Again, let me tell you idea 3. Idea 3 is order. Order of, for example, suppose A mod n is, or mod m is, for example, D. It means what? D is the smallest positive integer such that A to the D mod m is 1. Okay? It is definition of order. Idea 4 is that if order of A mod m is D, and for example A to the power of something, for example A to the k mod m is 1, then we can conclude D divides m. Okay, the proof of this is so much helpful, but try to do this as homework, and if you had question, as I said before, feel free to send message to my WhatsApp number. Now, here, I want to find order first. So n1 doesn't work because 2 is not 1 mod 5. 2 squared is 4, 4 is not 1 mod 5. 2 cubed is 8, is 3 mod 5, not 1. 2 to the 4 is 16, is 1 mod 5. So 4 is the order. So because of idea 4, we know that because order of 2 mod 5 is 4, and we know that 2 to the n should be 1 mod 5, so we can conclude 4 divides n. Third important result. So we know now 9 divides n, 7 to the 5 divides n, and also 4 divides n. Now we can say, okay, so n is what? N is, for example, 4 times, for example, s. Now, 149 to the n minus 2 to the n, we can write it as 149 to the 4s minus 2 to the 4s. So we can write it as 149 to the 4 to the s minus 2 to the 4 to the s. Now we want to apply LTE here. Our x is 149 to the 4. Why is this? We know p divides 5. If p is 5, 5 doesn't divide x. Here, 5 doesn't divide y. 5, I want to say, divides 149 to the 4 minus 2 to the 4. Why? Because if you consider mod 5, 149 to the 4 minus 2 to the 4, mod 5 is, we can say, negative 1 to the 4 minus 2 to the 4, which is what? Mod 5. Because 149 is negative 1. So negative 1 to the 4 is 1 minus 2 to the 4 is 16. So it will be negative 15, which is 0. Okay? So it will be 0 mod 5. So this condition is okay, this condition is okay, this condition is okay. This is x minus 1. Now we can apply LTE. V5 of 149 to the 4 to the s minus 2 to the 4 to the s equals V5 of 149 to the 4 minus 2 to the 4 plus V5 of s. Okay? So let's calculate this one first. V5 of this. Pause the video and try this part first on your own. Okay, let's focus on 149 minus 2 to the 4. So here we use identity 4, or idea 4, idea 5. We can use a squared minus b squared, which is a minus b times a plus b. Also, general form of this is a to the n minus b to the n, which is a minus b times a to the n minus 1 plus a to the n minus 2b. You should increase powers of a by 1 and decrease powers of b by 1. And the last one will be b to the n minus 1. Okay, if you apply for 149 to the 4 minus 2 to the 4, we want to find power of 5. It will be 149 squared minus 2 squared times 149 squared plus 2 squared. Then we can write it as 149 minus 2 times 149 plus 2 times 149 squared plus 2 squared. This one is not multiple of 5, this one not multiple of 5, so only we should focus on this. We can consider mod 25, this number. 149 squared plus 2 squared. Mod 25 is what? It will be negative 1 squared plus 2 squared, which is 4 plus 1, 5. So it will be 25t plus 5. If we factor from 5, it will be 5t plus 1. So the power of 5 will be 1. Okay, so here power of 5 will be 1. Now you can also calculate 149 to the 4 minus 2 to the 4 and divide it by 5. Then you will see, okay, if you divide it by 5, the number that is left is not multiple of 5. So it's 1 plus v5 of s. We know this number 149, it is what? 149 to the n minus 2 to the 4n. N is 4s, we said. Okay, here we said n is 4s. So we know this number should be multiple of 5 to the 5 from assumption of the problem here. 5 to the 5. So v5 of that should be at least 5. So we can conclude what? v5 of s, if we subtract 1 from both sides, v5 of s is at least 4. So n is 4s. And v5 of s is at least 4. So we can conclude what? Power of 5 is at least 4 in s. So 5 to the 4 divides s. Okay? Because n is 4s, 4 and 5 are relatively prime. So we can say it is equivalent that 5 to the 4 divides n. Okay, so it is fourth condition. Now if we combine all these conditions, it will be what? 9 divides n, 7 to the 5 divides n. Let's write them. Okay, our conditions are these. And the problem says what? The problem says suppose that n be the least positive integer that satisfy this condition. Find the number of positive integer divisor of n. Okay, let me tell you idea 5, number of positive divisors. Number of positive divisors. So at first let's find minimum n. N should be multiple of 9, so n is 9. The minimum n is n. 9 times 7 to the 5 times 4 times 5 to the 4. So we can say it is equal to 3 squared times, if you write it in order, in increasing order, it will be 2 squared because of 4, 3 squared because of this, 5 to the 4 because of this, and 7 to the 5. Okay. If you want to find divisor of that, you say, okay, the power of a divisor can be 2 to the 0, 2 to the 1, 2 squared. 3 cases. For power of 3, 3 to the 0, 3 to the 1, 3 squared. 3 cases. For power of 5, it will be 5 to the 0, 5 to the 1, 5 squared, 5 cubed, 5 to the 4. So how many cases? 5 cases. So in general, the formula, if n is p1 alpha 1 to pk alpha k, number of positive divisors will be alpha 1 plus 1, because power of p1 in a divisor can be 0 to alpha 1, 2 alpha k plus 1. And last one for 7, 7 to the 0 to 7 to the 5. So 6 cases. So it will be 3 times 3, 9, 6 times 5, 30, so 270. The answer is this. If you had any question or want to solve more problems from LT and other ideas in number theory and other topics, feel free to send message to my WhatsApp number in the description.